Hello. This question is covering the concept of initial conditions and boundary conditions, technically, because the initial condition is whenever you have a part of the function evaluating at x equals 0, so that's like an initial value at origin, something happens. And then it also says is satisfying conditions with double derivative. So it says that find a function f whose second derivative f double prime of x equals x cubed plus 2x squared plus 4. And then it has the boundary values f of 0 equals 1 and f of 1 equals 3. So this takes on that, as someone has already commented on one of the solutions, that you take the derivative twice. I'm going to break it apart piece by piece, and that to be able to do this, we're going to need to know a very well-known power rule, that x raised to some power n, the integral of x to the n in respect to dx, in respect to x, which you say by doing that multiplier dx, that is going to equal 1 over n plus 1 times x to the n plus 1 plus c being some arbitrary constant. You can have it any name that you want, as I'll show you. Because we were supposed to get two constants out of this, I'm going to show a way to be able to separate the two so that it doesn't get confusing really fast. So you add 1 to the power, that becomes the new power, and you divide by that new added 1 power. So in this problem, the example would then be as follows, that if you have x to the third, which the integral of sums is the sum of the multiple integrals, that's why I'm doing this very fast. So x to the third, add 1 is 4, divide by 4, so 1/4 x to the fourth. 2x squared, add 1 is 3, divided by 3 is 2/3 x cubed. Technically, x is 0 here because almost any number raised to the 0 is 1. So that's 4 times 1, so yeah. So 0 plus 1 is 1, so 1 over 0 plus 1, which is 1, is 4x. It's also just the integral of any constant, just puts on the x. Now this, you could call it C1 for like constant number 1. I have taken a different approach, and the first constant is some arbitrary constant a, which is going to be found for. Next, you have to take the integral of this new first derivative function. Same process, you set up that it's going to be the integral of the equation that you just copy and paste up into it. And then you'll have your second function, where applying again the same power rule, showing that you continue to multiply the new powers into the base, so that it can be left to the viewer that 4 times 5 would go to 20, 2 over 3 times 4 would simplify to 1 over 6, 2x squared from 4x integrating up, a going to ax, and then b being the extra constant that has to go into the end. So satisfying the first condition, that you plug in 0 for everywhere there's an x, and then all of that summation of that function is to equal 1. So f of 0 equals 1 equals 0, because it's x to the fifth. So it's just 0 times 0 times 0 times 0. Pretty sure I said it 5 times. Plus 1 6 times 0 times 0 times 0 times 0, still 0. Plus 2 times 0 times 0, still 0. Plus 0 times a, which still does not survive the multiplying of 0. That is still 0. Meaning b has to be 1. There's no other way to satisfy the condition without b being equal to 1. Then you have to do the f of 1 equals 3, which basically says that all of the x's raised to their powers are replaced with just multipliers of 1. So f of 1 equals 3 equals 1/20th times 1 plus 1/6 times 1 plus 2 times 1 plus a times 1 plus our newfound value of b being 1. You could handle this all with fractions. I didn't. I multiplied by the common multiplier of 60. You can find out that that's a common multiplier because 20 is made up of 5 times 4, which is technically made up of 2 times 2, 3 times 5. And 1/6 is made of 2 times 3. So the easiest way to do that is to multiply everything by 60, because then 60 over 20 is 3, 60 over 6 is 10, and then the rest multiply out to what they get. After a little bit of algebra, you kind of find out the arbitrary constant a is going to have a value of negative 13/60. Please check through this math and correct me if I'm wrong. I could definitely have done it wrong. I would like to know so that I can make the corrections as needed. But this means that the final function of f to satisfy the conditions must be f of x equals 1/20 over x, 1/20 times x to the fifth power plus 1/6 times x to the fourth power plus 2 times x squared minus 13 over 60 times x plus 1. Thank you. I hope this helps. Message me on the site if you have any questions. Thank you. Have a good day.